In this video, we have to learn 7-segment display connected to microcontroller. Here is a two type of 7-segment display, common cathode and common anode, and it is pin configuration of it. Now, first open FlowCode. After opening FlowCode, we have create a new flowchart. I am selected IC 16F887 and configure it at 4 MHz clock and internal oscillator and RE3 as a digital input output pin. Okay. Now first draw a flowchart. First, the output device is 7-segment display. Go to the external properties and you see here is the common anode and common cathode. I am selected common anode here. You can change the color also. Okay, now blue is already blue. Okay, here's a blue common anode 7-segment display here. The infinite loop is here and component macro. First, we have show a digit. First, we have show a digit of 5 and decimal point value is 0. So the decimal point is off. When I am running, the 5 is shown is here. Now go to the first, we have to save it now. After save it, we have to compile this program and then run it into Proteus. Now compile to hex file and open in Proteus. In Proteus, we have to select schematic capture now. In schematic capture, the peak device of 16F887 IC and a 7-segment display. We have need common anode 7-segment display. We have search a keyword as display and taking and searching 7-segment display. Here a 7-segment display common anode green. The color is green. And take this. Okay. Put a P16F887 IC here and a 7-segment display is here. Now in FlowCode and see where is the connection is. Common is connected to port A. I can change it now. No, it is not suitable. The port A common is connected at port A 3 number pin and segments are connected in port D. Done. Now compile it. Wait till compile is finished. Okay, compile and finished. Now go to Proteus and save the clock pulse at 4 MHz and take the hex file in here. Where I am to save it, the hex file is in there. And select the hex file and OK. Now I have to connect this. The segments are connected in port D and connect the segment here in port D. And common is connected to port A 3 number pin. Okay, all connection are complete. After that I run it. When I run it, you can see 5 is shown in here. Here's 5 is shown. Now go to the flow code. I'm taking a delay after that, and next time I'm taking another component macro and another delay. Take the delay as 500 millisecond. No, 1 second is correct. Okay, 1 second. And then another component macro, 7 segment display, show digit, and it is show digit as 3, and decimal point value is 0. And then another delay, and delay is 1 second. Okay, after run it, you can see 5 and 3. After 5 and 3, 5 and 3 are changing. And compiling it. After compilation finished, when go to the Proteus, and you can see 5 and 3 is shown. Finish the compile and go to the Proteus and run this. First 5 and 3. Another time 5 and 3. Okay. Now I'm making a counter here. There is two types of counter. One is up counter, another is down counter. I'm making a up counter now. So first we have to delete this delay and component macro. And changing for counting and gets another loop. This loop is end loop. To counting, I create a new variable. So name this variable as limit. Means if I put a limit as 5, then count is go to 0 to 4. If I put its limit is 7, then count is go to 0 to 6. Here is a limit. If check the limit value is 5, I'm check the limit value is 5. Then in component macro, the value of the digit show is limit, and the sum at delay is here. Take a delay of 500 millisecond. After compilation, the reset limit value is be reset. So limit is equal to 0. Now run it. When I'm run it, it will show 0. Why? Because I cannot increase the limit value. So I am increase the limit value one by one. In calculation, I put here another calculation after delay and take limit is equal to limit plus 1. So limit value increase 1 by 1. Okay, run it and it show 0, 1, 2, 3, 4 because the limit is 5. Now compile it. Go to the Proteus. I am run it and you can see here 0, 1, 2, 3, 4, 0 because the limit is 5 and it is successful in circuitry in practical. Now I'm going to flow code. I'm take limit value as 8. So it is count 0 to 7. Okay, compile it. Okay, compilation done. Close the window and play it in here and see 0, 1, 2, 3, 4, 5, 6, 7. Okay, another time compile this and recompile it. After compilation, I am close this window and go to the Proteus, and you can see the value is 0 to 7. The count is 0, 1, 2, 3, 4, 5, 6, 7, then 0, 1, and it is a up counter. If I put the value greater than 10, what happened? Because 10 is a 2-digit number, and put here 13. 13 is a 2-digit number. What happened? When count is goes to 9, after that it will not shown. When 13 is come, after that it will reset to 0 and will be shown, because there is a 1 digit here, and after 10 it is 2 digit. Okay.